Welcome to Intro to Parabolas with the focus and directrix. First, let's talk about what we know about parabolas. We know that they are a U-shaped that can go up or down. We know that they are in the form of ax squared plus bx plus c. And we know that these are called quadratic equations. Today, instead of thinking of it as ax squared plus bx plus c, we're going to think about parabolas with a new definition. So a parabola is also the set of all points in a plane that are equidistant from both a point, which we call the focus, and the line that we call the directrix. So if I take any point on your parabola, this one for example, if I go straight to the focus, the point, and straight to the line, the directrix, these two values are congruent. If I take another point on my graph, if I go straight to the focus and straight to the directrix, they're equivalent. Anywhere you go on this graph, to the focus and to the directrix will be the same distance away. And when you take all of those points, you end up with a parabola. Now, it is important to know that your focus is always going to be on the inside of the parabola, and your directrix is always going to be on the outside of the parabola. I like to say that the parabola hugs the focus, and the directrix should never intersect the parabola at all. Now, the vertex is a point equidistant from both the focus and the directrix, and it specifically lies on your axis of symmetry. We also know the focus to be the turning point. Now, at the vertex, the distance to the focus, and from the vertex, the distance to the directrix has a special relationship. We use this distance so frequently that we call it the letter p. Now, because p is a distance, it's always going to be a positive value, right? We don't talk about distance in terms of negative values. You're not negative 3 feet away from the door. You're positive 3 feet away from the door. So p is always positive. Going on, this is just a representation that shows how the parabola is actually made. You could pick any values, right? The L2s are the same distance. You could pick this one. This distance is the same as this distance. It just really shows how the parabola is made. Going on to identifying parts of the parabola. Your vertex, the turning point, which is right here. It has a coordinate of 1, 4. We know that the focus is supposed to be inside of the parabola, but right now I don't see any coordinate there. So instead I'm going to go on to what the directrix is. And the directrix is the line. So in this case, my line is a horizontal line, and horizontal lines are y equals, and it goes through the value 2. If you have trouble remembering x equals or y equals, in your calculator, go to y equals, plug in 2. It'll show you that it's a horizontal line, which is what you wanted. Now, in order to find your focus, we need to count the distance from the vertex to the directrix. And it is 2 units away. So if I go from the vertex down 2 units to the directrix, I have to go up 2 units to get to my focus. And that coordinate of the focus is supposed to be 1, 6. So my x value didn't change because the vertex and the focus are supposed to be in line, but my y value changed because I knew that my p value was equal to 2. Try finding the values for the next one and then resume the video. And the next one, your vertex in the center, well, between the 2 points, your vertex is at -4, 2. The focus, which is inside, is -5, 2. And the directrix, which is on the outside, is a vertical line. And vertical lines get x-equal equations. And it goes through the x value of -3. Now try and figure out what the p-value is here. If you go from the vertex, that is 1 unit over to the focus. And if you start at the vertex and go to the directrix, that is also 1 unit over. So my p-value is 1. Now let's actually talk about the equation going on here. So we're used to y equals ax squared plus bx plus c. Let's take an actual minute to step aside for a second. If you have y equals x squared, we're used to these parabolas going up, right? If you have y equals negative x squared, these parabolas go down but why? And they go down because they have a reflection, right? When you have a negative in front, that's a reflection over your x-axis. Now, if you have y equals 8x squared, what's the 8 do? What type of transformation is that? That's actually going to be a stretch. So that's going to control, the number in front controls how wide your parabola is or how narrow. Now the only difference between these equations, that they're in y equals, and the other equations is that we have x squared equals or y squared equals. So instead of y to the first equals, we have the term that's squared being isolated. Now when you have x squared equals 4py, you actually have to remember this. So make a note that you have to memorize it, because it is not on your reference sheet. You have two options with these equations. You have if it's positive, in which case you have x squared equals positive 4py. And positive x squareds, as we saw before, open upward, right? Your vertex is at the origin. Your focus is inside the parabola. And your directrix is outside of the parabola, never intersecting the actual parabola. We make the directrix a dashed line because it's not actually there, right? When you graph parabolas, we never see the focus and directrix. It's still there, it's still the relationship between the focus and directrix, but we don't see it. So keep it as a dashed line. Your other option is when you have a negative out front, as in x squared equals negative 4py, which because of that reflection is now going to go downwards. Your vertex is still at the origin. The focus is inside being hugged by the parabola. Directrix is on the outside. Now if x squared goes up and down, can you imagine where y squared goes? If you have positive, so y squared equals positive 4px, that's going to open to the right, right? If you had a positive x squared, you open up towards positive y values. If you have a positive y squared, you open to the right towards positive x values. In this case, your focus is going to be on the right inside of the parabola, and your directrix is going to be on the left, away from everything that's happening in the parabola. And your last option is y squared equals negative 4px, because you have a negative out front. So instead of opening to the right, you're going to open to the left. Focus goes inside on the right, on the left, and your directrix is now on the right. Let's try an actual example of writing the equation given the picture. You're going to want to find all of your key information first. So first you're going to look at to see where the parabola actually opens. And this parabola opens upward. If it opens upward, we know that it's going to be x squared, right? And that more specifically, it's going to be a positive. Next, you're going to want to find the vertex, which in this case is at the origin, so it's 0, 0. And your value of p. So count from the vertex up to the focus. Double check that you counted properly by counting from the vertex down to the directrix. So p is equal to 2. So we have x squared equals positive 4py. Now, if you think back to circles, when the center of the circle was at the origin, you had plain old x squared plus y squared equals whatever, right? Because since your circle was centered at the origin, you didn't have to adjust your x and y values. Well, our parabola is at the origin, the vertex is, so you don't have to touch your x and y values. They stay the same. The only thing that changes is the value of p, which we found to be 2. And you're going to simplify this to 8y. You do not need to solve for y, unless it's a multiple choice question, in which case sometimes they give you y equals as your answers, and you're going to have to adjust it. But if it's a free response, leave it like this. Why don't you try finding the key information of the next one, and then check the video when you're done. This parabola is opening downwards, right? Which tells me that it's going to be x squared, but this time it's going to be negative. Your vertex of this parabola is still at the origin, and to find the value of p, I'm going to start from the vertex, right? And I'm going to go up to your directrix, and that value is 6. Now, I don't have something else to check with because they didn't give me the focus. However, if I wanted to find it, I would count down 6. And now I know my focus is at 0, -6. Not that it's related to this problem, but that's how you would find it. Now that you have all your information, you're going to write it out. We have x squared equals -4py. Our vertex is at the origin, so you do not have to change your x or y values. And you know that p is equal to 6, so you're going to simplify. We get -24y, and you are done. Let's try a slightly different example. This parabola opens upwards. So again, we have x squared and positive. However, this time my vertex is not at the origin. My vertex is at 3, -2. And my value of p, if you count from the vertex up to the focus, that is going to be a value of 3. Or you count down to your directrix and you still get 3. So p is 3. We're going to start out normally, and we have x squared equals 4py, and we know that p is 3. So we get x squared equals 12y. However, this is for a parabola that has its vertex on the origin. In this case, our vertex is shifted, so we have to incorporate that transformation into our equation. Look back at the top with the circle. If you have x minus 4 squared plus y plus 3 squared, we know this circle is shifted, right? Because the center is no longer at the origin. The center is at 4, -3. So as you go between the equation and the center, you have the opposite values, right? You have a x minus 4, but your center is at +4. You have a y plus 3, but your center is at -3. Because as you have your equation inside parentheses, you take the opposite values. So right now, my x value is 3. As I go into the equation, inside the parentheses, I take the opposite. So if I have a positive 3, I have an x minus 3 in my equation. For the y value, I have a negative 2. But as I go inside parentheses into my equation, I do the opposite of y plus 2. And you're done. If you're still struggling a little bit, watch the video and I'll explain the rest of the problems for today. Otherwise, try the next few examples on your own and then resume the video to see the solutions. This parabola opens to the right. So now we know that we're going to have a y squared, and because it's opening to the right, that is more specifically positive. Your vertex of this parabola is at negative 3, 1, and the value of p, if you count, the value of p is 2. So we're going to start writing the equation as y squared equals positive 4px. And you're going to incorporate the vertex in it. So my y value of the vertex was 1. Be careful, we're not putting the negative 3 just because it comes first in the vertex. We want the y value. So if we had that the vertex is at positive 1, in our equation we write y minus 1. Our value of p was 2, and our x-coordinate of our vertex was negative 3, so in the equation it becomes x plus 3. All you have to do to simplify is to multiply the p-value with the 4. And you're done. For example 7, this one's also opening to the right. So we still have something that is y squared and positive. Our vertex is now at the origin again, which makes things much simpler. And your value of p, if you count to the right to the focus, that's 3. If you count to the left to the directrix, that's also 3. So p is equal to 3. We have y squared equals positive 4px. We do not have to adjust the x and y because our vertex is at the center, and that means that there's no transformation going on. Our p-value is 3, and just simplify to write y squared equals 12x. Now this was a 2-point regions question, and first of all you had to know what it was asking. So this one is saying, what is the set of points equidistant from a line and a point? Just reading that, this is the definition of a parabola, right? So you should know we're talking about a parabola for which the line is the directrix and the point is your focus, not the vertex. So this right here, R is your focus, not the vertex. Now a good way to start is to find what your actual vertex is. Now the vertex is directly in the center between the focus and directrix. So you can count that if there's 4 units in between the point and the line, your vertex has to be halfway at 2. If you have trouble seeing that, what you can do is put your thumb up top on the directrix and your other thumb down beneath on the focus. You're going to move your top thumb down 1, your bottom thumb up 1. Move the top down 1 and the bottom up 1. Your thumbs will intersect in the center where your vertex is. Once you find the vertex, you need to know which way the parabola is opening. If you draw it going up, you're going to hit the directrix, which is no good. If you draw it to either side, you're going to eventually hit the directrix. Still not good. So you do have to know Sorry about that. You do have to know that your vertex always opens up towards your focus. The focus has to be inside. So this vertex means that we are opening downwards towards the focus. Now because it's opening downwards, we know that you have x squared and negative. And our vertex is at 2, negative 1. Your p-value is 2. And if you were to go and write this equation, you have x squared equals negative 4py. You have x minus 2 squared equals negative 4 times 2 is negative 8. Y plus 1. This is your equation, but that is none of your answer choices because all these answer choices are in y equals. Makes things a little harder. Now you can solve to get y by itself, which is complicated, or you can look and try to cancel out options. I know this is supposed to be x squared and negative. All of my answer choices have an x squared and the negative in them, so that doesn't help me. The next thing that can help me is the vertex. And the vertex is 2, negative 1. So all of my x values in these answer choices are in parentheses. And if it's in parentheses, you take the opposite. If my x value is a 2, my equation should have a x minus 2 in parentheses. So that means it can't be choice 1 or 2. Has to be 3 or 4 because we have the x minus 2 going on. The y value is a negative 1. However, my y values, there's no parentheses around there. And if it's not in parentheses, you do not change the sign. In parentheses, you change the sign. Out of parentheses, you keep the sign. So I'm going to keep the negative 1 because it's not in parentheses. It has to be choice 4. Additionally, because these are all y equals, you could just put it in your calculator and match graphs. You know that the vertex is at 2, negative 1. So when you put these in the calculator, look at the graph, but then also look at the table to see which one has that vertex at 2, negative 1. And that's all for this video.